Hello everyone, this is day 4 of our data science series. In this video, we are learning about the exploratory data analysis. So, in this first, how to construct a bar graph with overlay using Python. A bar graph is a graphical representation of categorical data. It is often used to compare different categories based on numerical values. An overlay bar graph allows us to compare two or more data sets side by side, overlaying them on the same plot for easy comparison. In an overlay bar graph, we plot multiple bar charts for different data sets on the same axis. The bars of each data set are slightly offset from each other so that they can be clearly distinguished. Now let's see the example of it in our Google Colab. Just go to Google Colab. So this is the example of constructing a bar graph. Here it imports the matplot library .pylot and import numpy package. Here it is the sample data. It is the position of bars on x-axis. Here we create a bar plots, and here we add a labels on the bar graph, and it is the legend functions, and it is show function to show the bar graph. So this is the output in which we create a bars on the x-axis. The red bar is dataset 2 and the blue bar is dataset 1. Now second, how to construct contiguency tables using Python. A contiguency table, also called a cross tabulation or cross tab, is a table used in statistics to show the frequency distribution of two or more categorical variables. It helps to understand the relationship between two variables by displaying how many instances there are for each combination of their values. For example, a contiguency table might show how many males and females bugged or did not bugged a by a product. Let's see the example of this in our Google Colab. Second, here we are constructing a contiguency table using import pandas package. So here data variable contain the sets of two sets, gender and preferences. Here in this line we create a data frame. In this line we creating a contiguency table and print the contiguency table through print statement. So this is the output of our contiguency table. Preferences coffee, tea, gender female, male. Now let's see the third part. Third is how to construct histogram with overlay Python. Histogram is a graphical representation of the distribution of numerical data. It shows how often each value appears within a range called beans. An overlay histogram is used when you want to compare the distributions of two or more data sets on the same graph. Let's see the example of this in our Google Colab. So this is the code for constructing an histogram. Here we import a matplot library and numpy package. So data 1 and data 2 is the sample data, and plot 1 and plot or with the help of this two line we create a histogram. Or here adding labels, or with the help of show function we show our histogram. Let's run it. So this is the our histogram, where this purple part is data set 1 and this is data set 2. Now let's see the another part. How to perform binging based on predictive value using Python. Binging or uh, discretization is the process of transforming continuous data like ages, incomes, or temperatures into categorical beans. This is useful when you want to simplify the data or group into meaningful categories for further analysis. For example, instead of using raw age data, you could bin ages into categories like young, middle age, and old. Binging helps to make the data more meaningable, and it is often used for predictive modeling to categorize values for algorithms. Let's see the example of this in our Google Colab. So this is the code for performing beginning based on predictive value using Python. Here we import the package pandas and numpy. Here we set the data, and here we create a data frame on variable df. Here we define beans. It contains two lists that are called beans and labels. In this line, we create a new column with bean categories. Or here we display first few rows. Let's run it and show the output of this. So this is the output of our beginning based predictive value. So this is all about the exploratory data analysis. Now let's see the summary of it all. Overlay bar graph useful for comparing categorical data between two or more groups. Contingency table help to analyze the relationships between two categorical variables. Overlay histograms ideal for comparing the distribution of multiple datasets. And beginning transformation continuous data into categorical beans for simplification or predictive modeling. So thank you everyone. This is all about the our exploratory data analysis in data science. Thank you everyone.